Very good morning to all of you. This is your mathematics class. In the previous class, we were doing the topic sets, and which is chapter number 19 of your book. And in today's class, we will continue this chapter. But before that, let us recall all these things which we have done in the previous class. So what we have studied in the previous class, first one is sets. So basically we studied that sets is a collection of well defined and related objects. Okay, the next is we studied that what is the elements of set. What is elements of sets? We generally study that elements of set, just like we have, just a second, just like we have some numbers 1 2 3 and 4, and we put them in within the curly brackets 1 2 3 4, and we separated these numbers by commas and end up with the curly bracket. Now these 1 2 3 and 4 are the elements. So this is the element. The next we studied about the representation of sets, and the representation of sets in two ways. We have the representation of sets in two ways. The first one is roster form or listing method, you can say roster form or list form, and the second one is set builder form. So what we studied about the roster form, it's generally it's simply within the brackets and number of and the elements which are separated by comma, just like we have 1 2 3 within the curly brackets and separated by commas. These are the curly brackets, these are the elements, and these are the commas. So these elements separated by commas. So this roster form is simply this. The second one is set builder form. Suppose we have 1 2 3. So how we can write this roster form? How we can write this roster form in the set builder form? We can write it as starting with the curly bracket. So this we call set of now x, which is called all x. This x is called all x. Now we have these two dots which called such that. These two dots called such that. The next is here we can see that elements are 1 2 and 3. These are the natural numbers which is less than 4. These are the natural numbers which are less than 4. So we can write this x is less than 4. But here we x is less than 4. If we write x is less than 4, then it can also be minus 1 minus 2 0 and 1 2 integers, whole numbers, etc. Okay, so it is necessary to define that what is x here. X is less than 4 where x belongs to. This is the sign of belongs to. X belongs to natural number. X belongs to natural number. See, set of all x. Set of all x. This x define this set. That's why we called all x. Such that x is less than 4. Where x belongs to natural number. So this is the set builder form. About Venn diagram we will study in the next class. Now in the previous class we were doing question number 2, and today we will start with the same question. This is the question number 2. If A is equal to set of 1 3 4 5 11, then write which of the following statements are true. I already told you that this is the sign of belongs to. This is the sign of belongs to. Then this is the sign of not belongs to. This is belongs to. This is not belongs to. So what do you mean by belong? That means a thing which belongs to or which is contained in the another thing. okay, and the opposite of belongs is not belong. So you have to see in the first part the statement is 1 belongs to A. Here A is the set which is given to you, and A is the set which is containing elements 1, 3, 4, 5 and 11, and this one is the elements. This one is should be the element of this A. So the meaning of that statement 1 belongs to A is this set A contains 1. This set A contains 1 means you are given a set A, and in that set 1 is given. Is it here? Now you have to see, is 1 here in the set A, because the set A is this. So you have to see that is 1 here. Yes, we can see 1 is here in the set A. So we can say 1 belongs to set A. So this statement is true. Belongs to means element should be in this element should be present in the set. Element should be present in the set. And not belongs to means element should not be present in the set. See here 12 is not belongs to A. So you have to see, is 12 present in the set A? Set A is this. So is 12 present here? No, we cannot see 12 any of out of these elements. So this statement is also true, because 12 is not present in the set. That's why 12 does not belongs to the set A. So this statement is also saying that 12 is not belongs to the set A. So this statement is true. Now 4 is not belongs to A. So you have to see, is 4 present in this set? Yes, here 4. Here is 4. So 4 is present in this set. If 4 is present in this set, then we can say that 4 belongs to set A. But here you are given the statement is 4 not belongs to A. That means this statement is false, because 4 belongs to A. Now 5 belongs to A. So you have to see, is 5 present in this set? Yes, we can see here 5 is present in this set. If 5 is present in this set, then we can say that 5 belongs to set A. And this statement is also saying 5 belongs to A. So this statement is true. Now 7 belongs to A. So you have to see, is 7 present in the set A? Is 7 present in the set A? This is the set A. See why this is set A, because this is a set which is equal to A. That means we can say that this is the set A. Okay, so is 7 present in this set? No, we cannot see 7 as the element in this set. So 7 does not belongs to A. Does not belongs to A. But this statement is saying that 7 belongs to A. So this statement is false. Hope you understand this. If you have any problem regarding it, then you can ask. Now see the question number 3. Question number 3 is saying, write the following sets in roster form. I already told you that how can you write any statement or any set in the roster form. Roster form is simply within the curly brackets and separated by commas. So see how can you first part write. The first part is saying A is equal to set of for all x such that x belongs to natural number. Here capital N denotes natural number. Capital N denotes natural number. And x is greater than 5 but less than 15. X is greater than 5. That means x lies between 5 to 15. So it is clear from here that x is greater than 5 and x is less than 5. This is the sign of less than, and this is it is open towards the x. That means it is x greater than 5. So how we can write, first of all, this is the set builder form. This statement is given in the set builder form. So we have to convert this set builder form in the roster form. How we can write this set builder form in the roster form? See the solution of this question. Here we have question number 3 part A, which is A is equal to set of for all x such that x belongs to natural number and x is greater than 5 and less than 15. So how we can write? X is greater than 5. The numbers which are greater than 5 are and also it should be the natural number. So it is natural number, always the positive number which starts from 1, and we require here greater than 5. So greater than 5 is 6 and less than 15. So it will be 6, 7, 8, 9, 10, 11, 12, 13 and 14. These are the natural numbers which are greater than 5 and less than 15. So this is the roster form, or you can say that this is the list form. The next is part B, and part B is saying B is equal to for all x, set of for all x such that x is an alphabet in English language between H and O. That means we have to write down alphabets from H to O, between H and O. That means after H, between H and O. That means we have to write the alphabets which falls between the H and O. That means after H and before O. After H and before O. After H we have alphabets H, I, J, K, L, M and N. These are the alphabets which falls after H and before O. It is saying that between H and O, between, that means between H and O. Between H and O we have I, J, K, L, M and N. So these are the elements which are required here. So set of B is equal to I, J, K, L, M and N. These are the elements which are separated by commas and these are within the curly bracket. So this is the roster form. The next is part C, which is saying C is equal to set of for all x such that x is an integer from -3 to 5. That means -3 to 5. It is saying from -3 to 5. That means -3 and 5 is also includes here. -3, if it is saying from -3 to 5, from -3 to 5, that means -3 and 5 also includes. If it is saying between, then if it was said between, then -3 and 5 would not be included, but that at this time it is saying that from -3 to 5. It is saying from -3 to 5, that means -3 and 5 also includes here. So make a number line. Here we have 0, 1, 2, 3, 4, 5 because we required only till 5. And here we have -1, -2, -3 because we required till -3. So we have -3. This is the simple way to understand. If you want, then you can write, and if you don't want, then you as your wish. Okay. So C is equal to curly brackets and separated by the commas, number elements separated by commas, and elements are -3, -2, -1, 0, 1, 2, 3, 4, 5, because it is saying from -3 to 5. That means we have to move from -3 to 5. That means we have to move to the right hand side. Okay, and right hand side we have the values -3, -2, -1, 0, 1, 2, 3, 4, 5. So these are the required elements. Okay, and this is the roster form. Hope you understand this. The next is part D. Part D is saying that X such that X is a letter of the word permutation. You have to write these alphabets as a elements. These alphabets in the form of roster form, and which is within the curly brackets and separated by comma, just like P, R, P, E, R, M, U, T, A, I, O, N, S. Okay, you have to separate all these alphabets by the commas. You have to do it yourself. Now the next is question number 4. We have done question number 4 in the previous class. Now let us move towards the next topic. Let us move towards the next topic, which is types of sets. And in this we have first of all we have singleton. It is clear from the name single. Single means only one. Single means only one. That means a set which has only one element. A set which has only one element is called singleton set. Just like we have to write a prime number which is even. We have to write a prime number which is even. So a prime number which is even is only 2. We know that prime number are which have the factor of itself. That means which cannot be divided by any another number, which can only the factor is 1. So 2 cannot be divided by any another number because 2 is the smallest number. It has a factor only 1 and 2 itself. Okay, so this is a prime number which is even also. That means in a set we have only 2. We have only one element which is 2. So this is singleton set. This is singleton set. Hope you understand this. Now the next one is null. Null, that means 0. Simply null, that means 0. Null means which have nothing. Null means which have nothing. Empty, खाली, जिसके पास कुछ भी नहीं है. That means the empty set or the null set. That means a set which have no element. A set having no elements is called an empty or the null set. We simply write it as this. We do not write any element within these curly brackets, or we can simply write it as this. This called phi. This called phi. This called phi. And if we want to write the null or the empty set, then we have to write curly brackets without any element, or we can write it as phi. This is phi. We can write it as phi. Now the next one is finite set. So what is the finite set? As it is clear from the name finite, which is fixed. Finite, that means which is countable. So a set is called finite if it contains a countable number of elements. If it contains countable number of elements. Suppose we have to write the numbers from 1 to 10. You have to write the numbers from 1 to 10 in the roster form. So how you will write it? How you will write it? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, let's finish it. So this is the finite set, because in this set we have finite number of elements which are countable. And the infinite is just opposite of finite. That means a set is called infinite if it contains an uncountable or infinite number of elements. Uncountable and infinite number of elements. Suppose you have to write all the even numbers. You have to write all the even natural numbers. So even natural numbers are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 up to just like 98, 100 and so on, just like 998, just like 1000 and so on. So it will go so far. Okay, it will go so far and goes to it will go up to infinity. So this is not the finite. That's why it is called infinite set. That's why it is called infinite set. I hope you understand about the singleton set, null set, empty set, finite and the infinite set. So let us do the question based on this topic. See the question number 5. Question number 5 is saying, which of the following are the examples of the null set? Null, that means empty set. That means empty set which have no element. So see the first part. Set of even prime numbers. Set of even prime numbers. I already told you that even prime number is only 2. Even and also prime is only 2, because the prime numbers are which have the factor only 1 and itself, which can be divided by itself only and cannot be divided by any another number. That means these numbers are 2, 3, 5, 7, 11, 13, 19, 17, 23 and so on. But as you see that these all these numbers are the odd numbers. All these numbers are the odd numbers. But 2 is a prime number which is even. 2 is only the prime number which is even. So set of even prime number is this. Okay, is this. Now this set is containing one element which is 2. So this is singleton set. This is singleton set. But it is asking about the null set. So this is not the null set. The next is set of odd natural numbers which is divisible by 2. See, what are the odd numbers? The odd numbers which cannot be divided by 2. Odd numbers which cannot be divided by 2. And it is asking about the divisible by 2. So the definition of odd natural number is which cannot be divided by 2. But it is saying that divisible by 2. So it cannot be possible now. So it cannot be possible. So this set will not contain any element. This set will not contain any element. So you can write it as, or you can write it as. Now this is null set. So this will be the null set. You have to do the C part by yourself. Now see the question number 6. Question number 6 is saying identify the following sets as finite or infinite. Now remember finite, which is countable. A set which have the countable number of elements, and infinite which do not have countable number of elements, or you can say that which have uncountable number of elements. So how will you do it? See the A part. The set of month of a year. The set of month of a year. You know that A year have 12 months: January, February, March, April, May, June, July, August, September, October, November and December. So you can write it in the set form. This January, curly brackets, January, February, March, April, May, June, July, August, September, October, November, December, and end up with a curly bracket. So you can count these 12 months. You can count these 12 months. So this will be the finite. This will be the finite set, because you can count the number of months of a year. The next is set of animals living on earth. See, there are so many animals which are living on the earth. So these are infinite. We cannot count them. So this is infinite set. The days of the week also, this is finite, because days of the week are fixed: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. So you can write Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and end with the curly bracket. So this can be a set and these are countable. So this will be the finite. The set of numbers which are multiples of 3. Set of numbers which are multiple of 3. See, 3, 9, 27, 30 and so on. So this will be the infinite, because it will go so far. So this will be the infinite. Now let us move towards the next topic, which is cardinal number. What is cardinal number? Cardinal number of a set. Cardinal number is, you can simply say the number of elements. The number of elements called the cardinal number. Cardinal number of a finite set A is the number of elements in the set A. That means if you have a set A which have the elements A, E, I, O, U. A, E, I, O, U. Now, how many elements are present in this set? How many elements are present in this set? First is A, E, I, O, U. That means 1, 2, 3, 4, 5. That means 5 number of elements are present in this set. 5 number of elements are present in this set. So, cardinal number of set A is 5, and you will denote it as number of elements in set A. Number of elements in set A are 5. So the cardinal number is equal to the number of elements present in the set. So you have to find cardinal number of the set. A have 2 elements, so cardinal number is 2. B have 3 elements, so cardinal number is 3. Here C do not have any element, so cardinal number is 0. And here you should not be confused by this 0. This 0 is in the curly bracket. That means this 0 is also the element. This 0 is also an element. Okay, so the number of element is 1 here. Okay, so this is not the null set, because in the curly bracket we have 0. Okay, which is an element. Okay, we do not see the number. We have to see the number of element. 0 is an element. That means 1 element is present in this set. Set of all Indian having 4 legs. This is not possible. This is not possible. Okay, so set of all vowels, you can write it A, E, I, O, U. These are the vowels, because we know that in English alphabet we have A, E, I, O, U are the vowels, and remaining numbers are the consonant. Okay, remaining numbers are the consonant. So set of vowels are 1, 2, 3, 4, 5. 5 are the 5 vowels. 5 vowels, that means number of elements are 5 here. So the cardinal number is 5. Now the next topic is equal set and equivalent set. Equal set and equivalent set, which is pairs of set. So what is pairs of set? What is pairs of set? It is of 2 types. First one is equivalent and second one is equal set. So what is the equivalent sets? Which have the same number of elements. which have the same number of elements is called the equivalent set, and equal set which have the same elements, see, which have the same elements called equal sets, and which have the same number of element. See the difference. Same element is the equal set and same number of element is the equivalent set. Equivalent set is denoted by this sign. Okay, and equal, you know, this is the sign of this. Now, what do you mean by same number of elements and what do you mean by same elements? See, suppose if you have set A is equal to 1, 2, 3 and set B is equal to 3, 4, 5. Now see the number of elements in set A. The number of elements in set A are 3, 1, 2 and 3. And the number of elements in set B are 1, 2, 3. 3 number of elements. So number of element is same. So this will be the equivalent set. You can write it as A is the equivalent set to B. Now what do you mean by same element or the equal element? See, suppose if you have A is equal to 1, 2, 3 and B is also 1, 2 and 3. Now this is also 1, here 2 is same, 3 is same. So these are the equal set. That means set A is equal to set B. Now suppose if you have set A is equal to 1, 2, 3 and set B is equal to 4, 5, 6. Now see here 1, 2 and 3, here 4, 5 and 6. No element is same here. No element is same here. So this will not be the equal set. Okay, so this is the same elements. If two sets have the same number of elements, then this will be the equivalent set, and if two sets have the same elements, then it will be the equal set. Now there is one more thing. That equal set always equivalent. Equal set is always equivalent because see, equal sets always equivalent. See, here we have A is equal to 1, 2, 3, B is also 1, 2, 3. That means A is equal to B. Now see the number, count the number of elements in set A. 1, 2, 3, 3 number of elements. Count the number of elements in set B. 1, 2, 3, 3 number of elements. Number of elements are same, so this also be the equivalent set. That's why equal set is always equivalent set. Okay, but equivalent set may or may not be equal. Equivalent set may or may not be equal. Hope you understand. If you have any problem regarding this topic, then you can ask. Now let's see the question number 8. Find the pairs of equal sets from the following. We have to find only the equal set, not the equivalent set. See, here we have 4, 5. Now you have to see the set which contain 4, 5. The set B have 5, 4 and set B have 5, 4 elements and set A have 4, 5 element. See, 5 is present in set B, so you have to see that is 5 in set A. Yes, 5 is also in set A. 4 is in set B and 4 is also in set A. That means A is equal to B. Okay, they have same elements 4, 5 or 4, 5. Doesn't matter order of the element. It can be 4, 5 or 5, 4. Still these are same because both the sets are containing the same elements 4 and 5. So A is equal to B. Now no set is equal to A and B. Now C is 4, 5, 5, 5, 4. You have to see, is it anywhere? No. 2, 3. Is it 2 anywhere? 3, 2. That means set D is equal to set G. Doesn't matter it is 2, 3 or 3, 2. Order doesn't matter here. Only the elements matters here. Okay. 4, 7, 7, 4. That means E is equal to F. Hope you understand this also. This is the answer for question number 8. Now see the question number 9. What's the question number 9 is saying? Select the pairs of equivalent sets from the following sets. Equivalent sets, that means which have the same number of elements. Which have the same number of elements is the equivalent set. So you have to see question number 9. A part. X, for all x such that x is a vowel in the English alphabet. So how can you write it in the roster form? First of all, you have to convert this set builder form to the roster form. How can you write? It can be written as A, E, I, O, U, because it is saying vowels in English alphabet, and vowels in English alphabet are A, E, I, O, U. That means 5. You can write number of elements in set A is equal to 5. Now also B have the number of elements in set B is equal to 5. 1, 2, 3, 4, 5. That means A is equivalent to B, or you can write A is equivalent to set B. Okay. Now X is a natural number less than 10. X such that X is a natural number less than 10. So you can write it as C as 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the natural numbers. That means number of elements in set C are 9. Now the next is number of elements in set D are P, Q and R 3. E, X such that X is a positive divisor of 4. X is a positive divisor of 4. So how can you write it? Just a second. Just a second. How can you write it? E is such X is a positive divisor of 4. Divisor of 4 is 4, 8, 16, 20, 24 and so on. So it is not possible. Okay. Neither set is divisor of 4. Only A is equivalent to B. Hope you understand all these things. If you have any problem regarding any topic, then you can ask. Now exercise 19.1 has been completed. So you have to write down all these questions in your fair notebook.